Alright, so we are working through 18C, and in this video I'll be going through question 3, which is asking us, the curve with the equation this has a stationary point at 1, 2. When x is 0, the slope of the curve is 45 degrees. We need to find A, B, and C. So immediately we know that we're going to be dealing with simultaneous equations. We're going to be trying to find a series of equations which will help us identify what A, B, and C are going to be. So let's begin with the most straightforward piece of information, and that is we have been given a point on which the graph will lie. So let us come over here and say, well, we know we have 1, 2. Let us sub that into our equation and see what we get. That will be our first equation. So we're going to get 2 equals A 1 squared plus B 1 plus C. And then I'm going to tidy that up a bit. I'm going to get 2 equals A plus B plus C. Perfect. Let's call that, and we'll do it all in green. We'll call that 1. Okay, let's now do something else. We're also told that this coordinate is a stationary point. Therefore, what we can say is that when x equals, now I've already forgotten, when x equals 1, dy dx is going to equal 0 because it's a stationary point. So with this information, let us find another equation. So we're going to say dy dx equals, so let me first differentiate this. I'm going to have to look at it. So it's going to be 2ax plus b, and that is all. So then what I'm going to say is, all right, this is going to be equal to 0 when x is 1. So I'm going to put 1 in here, and I'm going to get 0 equals 2a plus b. And that is as far as I can go there. So that is going to be my second equation. Second. Perfect. So I have, let me do some highlighting. I have one equation here, which is good. That's number 1. I have my second one here, which is nice. But now I need to do it a third time with the information that I'm given here. When x is 0, the slope of the curve is 45 degrees. So when x is 0, the slope of the curve is 45 degrees. Now immediately alarm bell should go off because we're told it's 45 degrees, and we're probably asking ourselves, what on earth, how does that help us? We're not used to thinking in terms of degrees. So let me just, actually, you know what I'm going to do? I'm going to say, when x is 0, let me get a fresh color again. We're going to say when x is 0, my dy dx is going to be what? Well, this is where you have to put like a little dash here, and let's do some working out here. We are told that the gradient, my gradient, is going to be at an angle of tan of 45 degrees. Now, we don't like thinking in terms of angles. We like to think in terms of rise over run. So what we can do is we can picture what this is going to be. So remember, tan, right angle triangle, this is going to be 45. It gives us the ratio of my opposite over adjacent. And as you can clearly see, this is my rise over run. This is my rise over run, because it's just opposite over adjacent. And remember, you need to memorize what tan of 45 degrees is. It's just 1. So that means the ratio of my opposite over adjacent, or in other words, my rise over run, is going to be 1. That's my gradient. So that means I can come over here and say, well, when x equals 0, my gradient is going to be equal to 1. And then I can say, all right, that is my third way. I'm going to get my third equation. So I'm going to get dy dx equals 2ax plus b. So that's just what I had up here, just the differentiated thing, my derivative rather. So then I'm going to say this is going to be 1. Let me zoom in here. When x is 0, so it's going to be 2a0 plus b. 1 is going to be equal to, well, that whole thing is going to die because of that 0. 1 is going to be equal to b. Wow, that is really, really useful information. That's going to make this question a whole lot easier. I'm so happy right now. Okay, so if b is 1, then that means what we can do now is say sub 3 into 2. So that means I'm going to take my second thing right here, which is 0 equals 2a plus, now instead of writing b, I can write 1. And then I can solve this. This is going to be negative 1 over here, 2a, Therefore, A is going to be negative a half. That is another unknown that we have just found. Fantastic. We are doing amazing right now. What we're going to do now is we're going to say sub B equals 1 and A equals a half into our first equation. Now, I can't even remember what our first equation was. What was it? It was this one. 2 equals A plus B plus C. I think we can remember that. 2 equals A plus B plus C. So that means where I see my B, I can put a 1, and where I see my A, I can put a negative a half, and then what I need to do is some calculations. So it's going to be 2 equals, well, negative half plus 1 is just going to be a half plus C, and then I'm going to subtract a half from both sides, which is going to leave me with 1 half on this side, 1 and 1 half, which is just 3 over 2. So just to slow that down for a second so I don't lose anyone, what I'm doing here is I'm going to subtract a half here, subtract a half here. 2 minus a half is 3 over 2. 3 over 2 equals C. Let me highlight that. They're my 3 answers. If you're in a test, please write down your 3 answers somewhere, which makes sense. So go like therefore my answer is going to be A is equal to a half, B is equal to 1, and C is equal to 3 over 2. Let me just check the back of the book. A is 2, sorry, whoops, A is negative a half, good. B is 1, and C is 1 and 1 half. Well, that's the same as 3 over 2. We have done it, everyone. What a great way to start the day with a little bit of maths. Hopefully that's been helpful to you, and this working out makes sense. I will see you in class. Bye-bye.